what's happening with vehicle. For example, if he just connects the vehicle, let's say this is a diagnostic serviceman laptop, and then he can connect to the OBD, and then he can interact with every single ECU in your vehicle, and then get you all the trouble codes to you. And yes, another thing is that I think I'm running out of time. Is it okay if we extend it for 5-10 minutes? I hope yes. Okay, let's go. I just want to showcase a lot of other things too. I was planning for a small demo, but I'm not sure if the time is there. We will definitely do it. Otherwise, I'll tell you the exact resources where you can install the virtual simulators in your laptops. If you have a Ubuntu laptop that is good enough, that I will definitely just remind me if I forget about mentioning that. And okay, so if you go to a lot of talks which are recently there on internet, any talks, Black Hat, DEF CON, most of the talks which are talking about hacking infotainment hubs are on other three ways. They'll either get a reverse shell from the console because the console is a Linux machine or Linux operating system. So the OS is Linux. So you will get a root shell via ADB, Android Debug Bridge, because they also use for Android Linux. Android, of course, uses Linux. Or you can somehow get a UART shell. There's another protocol called UART, UART, Universal Asynchronous Receiver and Transmitter. That is generally with the embedded side of it, embedded protocols, where you can get a shell into that particular embedded device for debug purposes. And then they'll try to control IO pins. They will either put in, slip in their program into that, or they will try to control the CAN transceiver. For one of the infotainment hubs, I still remember I was working with, they were having the main IVI capable of transmitting CAN packets to the vehicle bus. And then we were able to get a small folder, which is TMP folder, which is obviously read and write allowed because it's temporary. So we were able to get the ADB access to the infotainment hub. We just had to plug it, the IVI out of the vehicle, and then connect the USB, and directly allows us access. And then you go to the temporary folder, you write your script, and you execute your script via the terminal. And then you will be able to inject packets into the CAN, and then through that you can unlock the vehicle. Okay, when I say unlock the vehicle, it basically translates to that particular set of messages which I should be knowing, which will allow me to unlock. The same way it happens: unlock a door, unlock a car, or unlock the engine, or start the engine. Everything happens on a set of particular packets. If you know those particular packets, then definitely you can go and replay them. Now the question is, how should I be able to replay? Isn't there any MAC, message authentication code? Isn't there any time-based session key or something which will help me that, okay, it should not work at all? Yes and no. I'll just come there. But there are some short-range attacks such as Bluetooth, Wi-Fi, GPS, and medium or long-range key fob and TPMS. Key fob is something which I would like to show a bit snapshot. So this is from my working, and I'm not sure whether it's a picture from my assessments or like somewhere I picked it up. But this is how people use HackerRF. This is using HackerRF and GQRX. It's a very famous radio analysis tools. And 314.8 megahertz is where the key fob translation happens. So basically, you have a key fob receiver and then a command module in your vehicle. And then there is a push button switches. If you push it, and then it will transmit, and then the other particular receiver in your vehicle will pick it up. And then you can see the same thing happening on HackerRF, which is trying to analyze the whole spectrum. So basically, when you push your key, it will open your car. What generally happens is that if there is no rolling code is the idea of rolling code is that every time you click that button, it will change the code, and both the car and the sender knows which code is going to the next one. And generally, the hackers will try to eavesdrop and then capture this and then reply back so that they can lock or unlock your vehicle. So that's a very famous one. And to be honest, this is the exact in an embedded block diagram which happens and what happens to this. That's a very famous, but right now there are some very good, implementations of RF, which I recently saw during my assessments too, where people are using hardware-based ID parameters. For example, if you have a key fob, the particular chip number or particular version number of the chip, whichever you want, you can embed into that algorithm. So one part of your inputs will be the secret which you are putting into the key fob, and the other part will be whatever it is. And then you can combine these kind of parts and you give it as an input to the algorithm which is running in your key fob, and then it will transmit. So it becomes harder and harder to break into it. Again, Bluetooth, Nowadays, I don't see. There used to be very famous attacks called the Bracktooth and Swine Tooth. After that, in the Bluetooth 5.0 and 5.x, I haven't seen very good vulnerabilities which will brick the entire vehicle or will brick the entire HMI. GPS spoofing is there. You can spoof your vehicle. That is not protected. So if a vehicle gets a stronger signal, it will believe that is the right GPS. So you can spoof your own signal. There are already a lot of resources available, which I couldn't list here. I actually missed it. Next time I'll fix it. But yeah, you can definitely do that. Wi-Fi also same. If you have the SSL keys, you'll be able to decode everything. Imagine that your car is connected to a home Wi-Fi, and then it is trying to interact and download packets from the backend. And if you can get the SSL keys which are being used, you can actually extract them if you have access to the infotainment hub or the telematics control unit. And if there is such functionality where you can access them and then extract the keys and then collect all the you know backend communication via the Wireshark or like packet capture, and you can easily see each of the things happening. And then actually you can put an MITM tool to break the connection and then read or redirect them to a different one. But that's a different thing, and it's not just about the software which is coming. There are a lot of modern security controls in vehicles. For example, something called a secure boot, which will only allow the authorized certificates, based on certificates, of course, signed firmware update from the OEMs to be flashed into this. There is TPMS, there's key fob, there's cellular. Of course, I don't want to bore you through all of this. So if we say what is an automotive security as a whole, then there's definitely CAN bus, which is the main communication protocol between ECUs, and then Unified Diagnostic Services, that is the OBD2 and diagnostic trouble codes. The term for doing that is Unified Diagnostic Services, UDS. And for the modern vehicle implementation, such as telematics control unit, which is talking via cellular to backend, there's telematics, and there's infotainment hub, which combines with Bluetooth, GSM, radio, PKS, passive keyless entry, that you just have your key in your pocket and you just open the car, it unlocks because it can sense the sensitivity and it does the transmission without you pressing the button. There's third-party hardware and software solutions, that's an external threat. There is anything such as like AI or cloud control services that all becomes an external threat. So all of this comes under automotive security. All of this comes for attackers, attack surface. Okay. Generally, if you watch a lot of series, this is picked up from a series called Silicon Valley. There they were talking about a fridge, which is smart fridge getting hacked. But generally, that I thought of putting it because it actually paints the same picture which OEMs and Taiwan suppliers have. There's developers, there's security engineers. Developers want the functionality to be done. Security engineers they don't care about the functionality, they want to care about the security. But both of them eventually will work together to have a functionality which is secure, at least to the best they can secure it. And then there's always a question, everybody comes with their own points, and how do I evaluate everyone? And another challenge in automotive field is any car you see, it will take at least 3 to 5 years to develop that vehicle. From single scratch to design and manufacturing and everything, till the time it gets production gets started, not about whether it gets comes into the sales office or not. Till the time they think, okay, I want a new car, and the time to production where they start manufacturing. There are a lot of OEMs, and there is a lot of shared responsibility between suppliers and all of that. So to actually make sure everything happens properly, there is something called as TARA, Threat Analysis and Risk Assessment. So you basically identify the assets you would like to protect, and then you start rating them, and you see how that can be attacked and what is the feasibility of getting attacked and what is the risk value. And then based upon the risk, generally companies will take a determination decision that whether we'll live with this risk or we will change the architecture or change the functionality or change the firmware to fix this vulnerabilities or anything. So that is how it actually happens. That's how they share responsibility with suppliers, from who is supplying the part, who is selling them, who is putting it all together and manufacturing it, and who is developing different models for that. And if we see, there is a lot of, this is TRIDE, which is very famous for TARA, this is threat analysis and risk assessment. And then that being used, if we have firmware, then the code injection is a threat. Tampering is a code injection. Reverse engineering is information disclosure, what particular logics they are using. And then there's one famous thing. Yes, the network communication. It is both repudiation and information disclosure if you are able to do MITM, so etc. So we cannot go into every single one, but this is the whole big picture of it. Of assets. So again, this is a very small snapshot. This is not the entire one. There will be others which we might be able to miss here based upon the vehicle functionalities and features. So you have engine throttle control, again, coming to the assets, which we talk in a higher level from the functionality view, not the ECUs, but the functionality. Some cars will come with electric power steering, some cars will come with lane correction, some cars will comes with entertainment systems, some come with voice and data communications, remote keyless entries, all of the functions which you are trying to modernize and sell more, or picking up your attack surface and making it more and more bigger. Okay, coming back to the CAN protocol, I don't want it to be all theory. I just want it to be a little bit of practical, seeing what happens in a real vehicle too. So CAN protocol is a controller area network protocol, which is basically developed by Bosch back in 1990s and 86. And now it is being used in every single vehicle which we are taking, including Mars rover. Yeah, exactly. Not just vehicles, industrial manufacturing, and then rovers, which NASA is sending, and a lot of other embedded systems, aeroplanes, etc. A lot of places they are using it. The features for CAN protocol is message-based protocol. It is very robust. It is depending upon message. It is not based upon ID or IP. It is based upon what message the particular packet is sending. And it is a single wire bus. We will talk about wiring part. But then you would be asking, why is the features listed as message and robust? Why it is not listed as it has AES-256 encryption, or it uses elliptic curve cryptography? No, there is no encryption. There is no authentication, nothing. So if we put an OSL layer and then OSL layers and then CAN layers on side by side, CAN works on physical and or data link layer. There is nothing else apart from that. There is no network transport or session or presentation. And of course, there's one part of object or transfer layer is kind of split into two. Physical layer takes care of that single level bits. So CAN protocol works in bits. Of course, every protocol works in bits and bytes, zeros and ones. And then transfer layer takes care of fault confinement, message validation, message acknowledgement, and then arbitration, etc. And then object layer takes care of message filtering and stuff. So in CAN, there are two types of frames: the standard frame, there's an extended frame. The terminology is the part which I would like to focus. Anytime you see it's a zero, it's a dominant bit, which you cannot change it. It's a one, it's a recessive bit, it can change it. So what do you mean by changing it and all? We'll just see it in the next slide. So if you know what is MSB, most significant bit based transmission, and least significant bit based transmission, that's embedded terminology. So MSB is, let's say you have 1, 2, 3, 4, 5, 6, like around 9 bits. Okay. Based upon the first bit you're transmitting, either you're transmitting the right extreme bit or left extreme bit. That is the difference between most significant bit and least significant bit transformation. So of course, every single ECU in your car has to follow the same thing. So in CAN protocol, for CAN protocol, the data are transferred in MSB fashion, most significant bit first. So exactly like I was mentioning, no security implemented as it controlled as centralized vehicle. So this is again a little bit of electronics wiring. I was talking about whether it's a 0 or 1, why we cannot do. Imagine you have a voltage line. It's around 2.5 volts, and there are two wires with you, blue wire and red wire, and both of them are at 2.5 volts. If I create a voltage difference between those two, I will not be able to nullify the voltage difference. If I make some voltage difference between two wires, create a voltage difference, I will not be able to nullify them. But if there is no voltage difference, I can definitely make a voltage difference. That's a simple logic how CAN protocol works. And in bits and bytes style, let's say there are two nodes, two ECUs here. One is within trying to transmit a packet of ID 134, and then a second one is trying to transmit a packet of 144. I think I'm missing a slide. Yeah, I'm missing this slide. So basically, this is the entire CAN protocol packet. There's like we are talking about, these are packets. So I was mentioning, right? You need set of packets to do any action. So this is one such packet interpretation. And there's something called as arbitration, control, data, CRC, and end of frame. For our discussion right now, we'll focus on the arbitration and mostly about data. Arbitration is that ID, the least ID wins the bus, the least ID gets the access to the bus. So what do you mean by access to the bus? So for example, if there is an ID 134, which is least ID, and compared to 144, both of them wants to transmit their packets at the same time in in a vehicle bus. Then what happens is that both of them will transmit their first bit, which is the most significant bit, and then they'll try to see if the same value. So every time the node transmits to the bus, whatever the bit it want to transmit, it will also try to read from the bus whether it's the same bit on the node or not. I mean, in the entire CAN bus or not. So till here, everything will be same because of the binary representation. The moment it goes to the 8th bit, the node 1 transmits a 0 and the node 2 transmits a 1. But like we were discussing, in CAN, the voltage difference is considered as high, that is 0, and the 0 voltage difference is considered as 1. So based on that logic, we'll also see another slide there, which might be easy to understand. But based upon the logic, whenever the 0, there's a voltage difference, and then other person is saying there is no voltage difference, literally translating into English. So the node 144 understands that it should be no voltage difference in the bus, but when it tries to read the bus, it senses a voltage difference because the other node is trying to transmit a dominant bit. So 134 takes over the bus and it continues transmission of everything like we are seeing, control data and everything, and then it does an end of frame, and again the buses will go back to trying to figure out who gets the bus again and all these. So this way, every single packet goes. Since the protocol is specifically designed to make sure that they are not worried about security, or they're not worried about somebody coming and interrupting these messages. They're more worried about whether you're, let's say, you're driving at 60 kilometers per hour and you would like to slam the brake. And you're at the same time, you're also trying to increase the air control or air conditioning. So which message ideally should go first? It has to be the, what do you say, the air conditioning message or the brakes message? Of course, brakes. So brakes, generally passengers will get higher prioritization IDs. So they will not be able to win any other packets if there is a higher priority message in the bus. So, and yes, okay. So here you see whatever based upon the CAN high and CAN low. CAN is a twisted pairing wire. So you have two wires, CAN high and CAN low. So that's how we try to pick up the voltage difference. So when there is an voltage difference, you can see here, there's a very big voltage difference for this RTR bit, which is in sky blue color marked, but it is read as 0. So that is how it is getting read. If there is no voltage difference, it will be read as 1. And the same thing can be converted into bits here. So I was talking about the wiring, right? It is mainly designed for reducing the wiring. Let's say you have three ECUs, and there are like at least like 10 to 15 sensors. All these yellow things are sensors, and there's three ECUs. If you have to make sure every single ECU has to talk to every single sensor, then this is amount of wiring you have. So if you're from mechanical background, I was from mechanical background. So the more weight you add to the vehicle, the less mileage it will give you, the less efficient it will be. So they had to come up with a protocol like CAN. Bosch came up with it at first, and then what they were doing is that you can connect with a CAN bus, and each other people, all the issues like engine control or airbag system or dash panel, everybody can talk to each other via the CAN bus, and then it will reduce the wiring, improve the efficiency. The same way, also it is very much fault tolerant, because even if there is any electronic noises in the bus, it will not be able to diminish the voltage difference in such a level. So it will be also safe on that side too. Again, OBD, we were just talking about it, and even OBD runs on CAN. There is UDS, Unified Diagnostic Services, and then that in turn will talk to CAN. It works on top of CAN. And there are some service modes. This is all boring stuff. Unless you do it in very practical, you will not feel. But there is something which is very important here. So let's say there was a very recent vulnerability which didn't come to the limelight, but I'll give you a brief what it was. Uh, there was a particular vehicle manufacturer. They were selling a new feature that you can unlock your car using your mobile app. And the way they are doing it is with the customer registered mobile number and the vehicle identification number. So actually, if you have OBD access, you can actually request the vehicle to give you the vehicle information number, a VIN number. That's a vehicle unique number for every vehicle. And then once you get the VIN number, you can pull it into this particular application, which is a vulnerable application. And if you know the customer's mobile phone number, you can put any vehicle number and then a good correct pair of vehicle identification number and customer mobile number. The application backend will simply unlock that particular vehicle. That means you can pick up any vehicle if you know the VIN and then mobile phone number. So that kind of things happen. So all of these protocols and OBDs are the ones which will feed us the info, which will feed us the lead points from where we have to pick up the attack path. Again, on top of, like I was mentioning, on UDS works on top of CAN, diagnostics on over CAN, and it comes into network and transport. And then there's one on application layer too. There's a specific ISO standard for those exact things according to each layer, but that is mainly the concern of developers and then embedded developers, not us. Okay, that kind of brings us to the end of our session. These are a few of the resources you could want to do. I also see a question in the chat. Somebody was asking any references for beginner learning car hacking. I would say you should start with Car Hackers Handbook. That's a very good book, which was released back in 2015 or 17, I believe. I'm not sure about the exact year. And there is one more book which was released during my bachelor's, this during 2020 or 2020, 2019, Hacking Connected Cars. That's also a very good book. And you should read this paper, which is about the Jeep hack, remote exploitation of unaltered passenger vehicle. That will give you a big overview of things. And there's some research on Mercedes-Benz, T-Bone, CanSec West 2021 talk. So all of these talks and papers will pretty much give you the right direction if you want to pick up car hacking as a topic or a hobby or a job program. Yes, there are so many jobs which will tell you if you are into car hacking, they can give you a job as a cybersecurity engineer or a pen tester where you can earn money like how you would do the same with application security and also with the embedded things. So that brings us to our final Q&A. If you have any questions, you can tell me. Meanwhile, I'm also trying to pick up that resources I was mentioning. Uh, so let me just quickly get that. What do you say? The resources about the IV simulator. We don't have it now, or let me see if I can put it up. Maybe it just takes a minute or two. How about I do this? I just quickly show you. Yes. However, I do this, I'll quickly show you what happens. And then it's a very old tool and very, very good tool. If you want to pick up your car hacking skills, you should start there. It is not the end. Like I was mentioning, see, the new modern age implementations of CAN protocols are also secure. They are very having encryption like SECOC, secure onboard communications. And there are a lot of other features. It is not as simple as we see in this presentation, but this is definitely a pickup point. Uh, Wait, let me see if I can share my screen again. You should be able to see a cluster and then controls. This is a very famous tool called IC Simulator, which will help us to control things. So I just want to push it. So I'm just putting the pedal up acceleration button. You can see the needle is going up. Uh, so that basically we are trying to control a virtual simulator. And then the way we are doing it is through a virtual CAN network. And then you can see all the packets going on. This is all noise, but the more we interact with the vehicle, the more noise it produces. So in order to filter it, let's also filter it based upon packets which are getting changed. So here you can see all the packets which are getting changed. And let me go ahead and open few doors. I will first show you what happens in that. One second. Yeah. And also let me just increase the font. I believe it will be very hard to read it. Yeah. Great. Sorry. So I was telling you, right? Every action which will be happening on vehicles will be based on few packets. So here, to close all the doors, and my car is getting hacked, so it is not working properly. So, but you can see here, in the vehicle, there are no doors open. So I'll try to open the doors, and I'll tell you the exact packet which will be able to do. I know the packet because I worked on it with a lot of times. So that's why. So here you can start looking at ID 19B, and then the third bit, you can see here, this one, this 19B. I'm looking on a live sniffer. If the packets are not available on the bus, then it will not show you. So I'll try to put on the packets, but look for 19B, and then you will see the exact things which are happening. I'm trying to open all the doors and then close the doors. I don't know why it is not showing properly, but yeah, that's how it works. You can see every time I try to open a door or close a door, it is trying to show it up on 19B. And then every time we do that action, it will change one of the bit. So we are having a color coding here. So that is why you can see that. So this is the way actually you can also send this. For example, if I do this, let's see if it works or not. We were talking about arbitration and data, right? So the ID is the arbitration ID, 19B, and the data, let me just go on, hold on, I should be able to open all the doors. Yeah, see, whenever I press that, there is some flickering, but I don't know. It should actually open all the doors. Yeah, it closed all the doors. Fine, no problem. So this is a classic example of injection attack. Any modern POCs also you see they'll be somehow doing this. I'll drop this link in the chat box in a moment, so you can go check it along with that. So with that being said, of course, there's a Q&A. I will be needing Q&A. Thank you very much for having me. There are a few topics which if we might not be able to cover very deeply here. If you have any queries, you can definitely reach out to me over LinkedIn or Twitter, and then you can ask me all your queries for that. And there's a question: will the presentation materials be distributed later? Yeah, of course. I'll get a copy of the slides and I'll share it with the chapter leads, and you can collect it from them. And yes, that would be all I would say. Thank you very much. Now I'm open to questions.
Okay, thank you, sir, for your knowledge sharing today. So if any question, you can contact Mr. Led. Sir, you have email or other can share to another participant?
Yeah, I'll just drop it in the chat box. I'm just trying to get all the links about the ICSM. So
Okay. Okay.
I'll just drop my email there.
For presentation slide, we will share after this session. I will share to OWASP Jakarta group by WhatsApp or Telegram. Thank you, sir, for your session. It's very nice.
Thank you. I hope you liked it.
See you in next session maybe. Thank you,
Yeah,
sir.
sure. Okay.
See you
Thank you,
later.
guys. Bye-bye.
Thank you, Kar.